Hey folks, Mr. Dell here. We are looking at how to take and, given a rate, find additional information that might be proportional to that rate. So this problem I'm taking from CPM, and this is course 2, so CC2. This problem I'm taking out of the parental guide worksheet that is aligned to 4.2.3 and 4.2.4. Okay. And this is number 4 is what I'm doing. So it says Shane rode his bike for 2 hours and traveled 12 miles. Okay. At this rate, how long would it take him to travel 22 miles? So in the very first sentence, I am given a rate. The rate I'm given is 2 hours traveled for 12 miles. So remember, when we are given a rate, I like to write my rate as a fraction, right? So that's the first thing I'm going to do is write my rate as a fraction, 2 hours in 12 miles. So rate as a fraction is also known as a ratio. That's another word for a rate as a fraction. So 2 hours, I write 2 hours over 12 miles. That's my rate as a fraction or ratio. Okay. What's interesting though, this is saying 2 hours and 12 miles. So if I'm thinking about wanting to look at this and figure out now how long will it take him to ride for 22 miles, I want to take this fraction and find an equivalent fraction that has 22 miles as part of it. Well, I write another fraction, but I got to put the miles someplace, right? So if miles is in the bottom, then my second rate will also have miles on the denominator as well, right? So I have, in this case, 2 hours for 12 miles. And what I need to find is how long. Well, how long is my question mark. That's my how many hours for 22 miles. So now I've got these equivalent fractions, and I need to find that missing number there. So I'm going to rewrite these fractions without words so we can see the fractions itself and do the math. So 2/12 needs to equal 22 and something over 22. So I've got to figure out what times 12 is 22, because if I knew the common multiple to multiply the 2 and the 12 by, then I would have an equivalent fraction, right? So if this was a 24, it'd be easy, right? If I pretend that was a 24 on the denominator and I was taking something over 12 to be something over 24, I know that I would just multiply by 2. So I can see that. But it's a 22, so it's not going to be a nice easy number. So we have to think about what math would I do to figure out something 12 times something is equal to 22. Well, the opposite of multiplication would be division, right? If I want to know, hey, 12 times something is 22, I need to take 22 divided by 12 to find out what that something is. It's inverse operation here, right? Example, let me go to a little side note. If I wanted to find out 12 times something is going to equal, let's say, 84, right? And you didn't know your 12s, you didn't know what 12 times what was 84. How would you figure that out? How would you figure out what that something is? Well, you would do division. You would take 84 and divide it by 12 to find that out. And when you take 84 divided by 12, you get 7. So, okay. So then therefore now you know it's 12 times 7 is equal to 84, right? So that's how you find out what needs to multiply. So the same situation here, 12 times something to be 22. So I have to do division to figure that out. But when we do division, remember division can be written this way, but division can also be written as a fraction. So the division I'm going to do here, I'm not going to do 22 divided by 12 and get a decimal. I'm going to write it as a fraction. It's 22 over 12. So division, remember, can also be written as a fraction. This still means 22 divided by 12, 22 divided by 12, right? Those both mean the same thing. So, and I'm going to leave it like that. So I'm going to multiply then. I'm going to multiply 12 times 22 over 12, right? 12 times 22 over 12 is equal to 22. Because if you think about what's going to happen is anytime you're multiplying, and I'll show you down here, anytime you multiply a whole number times a fraction, you put the whole number over 1, and then you notice, oh, I have a 12 on the top and a 12 on the bottom. They cancel each other out. And in this case, you're just left with 22 over 1, which is 22, right? So that's why that works. 12 times 22 over 12 is 22. So that is the number that I'm multiplying the bottom by. So to make this a legal operation, I'd multiply the top by the same thing. That's your really giant 1 there. So I just got at this point figure out what is 2 times 22 over 12, and that will tell me my question mark on top. So let's do that math on the side here. So 2 times 22 over 12. Well, how do you multiply a whole number times a fraction? You put the whole number over 1, multiply straight across. 22 times 2 is 44 over 12. Now I've got to do the division here. And in this case, I'm going to leave my answer as a fraction. So I'm going to make this into a mixed number. So how many times does 12 go into 44? About 3 times. With what left over? Let's see. So 3 times 12 is 36. So 12 times 3 is 36, right? So then what's the difference between 36 and 44 is 8. So the answer would be 3 and 8 twelfths. So this is the division, but now it's written as a mixed number. And then 8 twelfths can be reduced to be 4. Nope, let's see. That would be 4 6. So actually it would be 2/3. I could divide top and bottom by 4. So 3 and 2/3. All right. So all of that. So let me go back. There's a bunch of computation here that occurred. I don't want you to get mixed up in the computation. I want you to understand that in order to find your missing value, you've just got to figure out what you multiply the denominator times to get the new denominator. Do the same thing on top, and that's your question mark. So I did that here, and I ended up with an answer of 3 and 2/3. So that 3 and 2/3 is my question mark. So the answer to this problem is that it'll take 3 and 2/3 hours, 3 and 2/3 hours for 22 miles. Right? So that's what I was trying to figure out, was how many hours it would take to travel 22 miles. And that's exactly the process of getting that answer. Okay? There you go.